Okay, so good morning everyone. Assalamu alaikum. So in this class, we'll be discussing about the linear motion part. Okay. Unfortunately, I cannot turn my video on for this class. Again, due to the technical difficulties. So I will show you the screen and teach. I think it will be okay. If you are not hearing me, please let me know in the chat. Or you can just unmute yourselves and talk also. Okay, which is more appreciated. Okay, so linear motion, by definition, this is a motion that happens in a straight line. Okay, there should not be any breaks or bends in the straight line. It's just a straight line. It can be horizontal or it can be vertical. In either directions, it is in a straight line. So then you call it a linear motion. You understand? There is a special type of linear motion that is not very linear when you just look at it, but it is called a linear motion, which is the projectile motion. Okay, that is a special type of motion that we will study later. But now let's focus on the straightforward linear motions. Okay, so when an object moves like this, you call it a linear motion. It's moving in the straight line, you call it a linear motion. Okay, there can be a lot of things happening to this object. Okay, so it can be just stay there, then you call it a rest. Okay, then you call it a rest. Or it can be moving. It can be moving. So then you call it a motion. The motion has a lot of parameters. When you are explaining, when you are describing a motion, you use a lot of parameters. Can you list some of those parameters, please? Yes? Just list. Give me a list. Just tell me. What are the parameters you use to describe a motion? So you use, I will start this, okay? You will use displacement. What else? What else? You use velocity. You use acceleration. Okay? You use acceleration. So these are the three terms that we are going to be using today. You know, there is something called distance, which is a scalar quantity, which doesn't have a direction. So it doesn't speak much about a motion if you don't describe it in terms of direction, right? So we don't discuss about distance much. We discuss about displacement, and we don't discuss about speed, which is a scalar. We discuss about velocity, which is a vector, and acceleration is the rate of change of velocity. There is another counterpart for acceleration, which is known as deceleration. That is not actually a physics term. When acceleration is in negative values, you call it a deceleration. Okay, so that is for, I mean, lay people to describe motion. But we can describe any motion in terms of just acceleration. And negative acceleration has another name called deceleration, but we won't be using it much. Acceleration is an umbrella term. Okay? Yes, okay. So now let's try to define these three words. So first, let's discuss about displacement. What is displacement? So displacement is the direct distance between, let me draw a diagram, then it will be easy for you. So I will draw the things in the same diagram. Okay, so I have shown a motion here. So after a period of motion, now the object is here. Okay, so let's say that the motion started when the time was 0 and it finished when the time was t1. So during this period of time, 0 to t1, the direct distance that has been traveled by this object is known as displacement. So in this diagram, we can show that this is the displacement. So what is the usual letter that is used to denote displacement? Just
S.
S. Okay, S. Okay, so I will be using standard symbols. Then you will have to understand. You should understand. Okay, so displacement is S. So displacement is very simple. Displacement, as it is a vector, it can carry two signs. Okay, it can either be positive or it can be negative. That depends on how you decide it. For example, so now you have decided to measure the displacement from this point. Okay, so you can just tell that I am going to measure whatever the displacement that happens in the right side as positive, and whatever the displacement that happens towards the left side as negative. Okay, so let's say this object goes there like this and come back, and it comes back like this to the original position where the displacement is 0. Then throughout this motion, the displacement was only positive. So it was moving in this direction, again moving back to the initial point, but always the position of the object lied in the right side, right? So it was always what? Positive displacement. But when it crosses this point, when this goes to this side, then you call it a negative displacement. You don't consider the direction of moving. Okay, you don't consider the direction of the motion. That is for the velocity. Displacement is just the position. If it is in the right side, it's always positive. If it is in the left side, it's always negative. These points may sound simple, but these are questioned in the questions. Okay, if you take 2019 paper, there is a beautiful question about a displacement time graph for two cars. So that question can be confusing if you don't understand this concept. So direction of the displacement only talks about what? The position, whether it is the right side or left side. Not only right, left, it can be east, west, okay, above, below. So if you take this 0 and upwards displacement considered as positive and downward displacement considered as negative, you can decide. So that is decided according to how you want it to be. There is no hard and fast rule for deciding a sign for displacement. Okay, do you guys get that? Then what about velocity? Velocity is a vector, so it has positive and negative signs. Okay, so when we define the velocity, we define it in terms of
Displacement.
what?
Rate of change of displacement.
Displacement, right? Yes. Yes, the rate of change of displacement as velocity. Okay, so velocity has direction. Okay, velocity, you describe it like this. Okay, let me take an example. So an object is like this now. So now you have to forget about the origin. Okay, so origin is important only for the displacement. When it comes to velocity, it is just the direction. If it is moving towards this direction, you consider positive, for example. If it is moving in the opposite direction, you call it negative. You don't look at whether the velocity is increasing or decreasing. You just tell it according to which direction it moves towards. Okay, it can be increasing velocity in this direction. It can be decreasing velocity in this direction, but you still call it this direction. You don't consider the changes. Okay, but when it moves in the opposite direction, it can be increasing, it can be decreasing, or it can be a uniform velocity, whatever it is, you call it negative velocity. You can change the direction if you want to. You can call this positive and this negative. So this is always about the direction of the motion. It's about towards, okay, towards what? But this is about position, okay, position, right side or left side. It can be moving in any direction. Okay, so this is the equation for velocity. I will explain the equations of linear motion later. So now I'm just talking about some basic stuff, definitions and all. Okay, right. So then we come to acceleration. So what is acceleration? You already told me. Acceleration is, yes, come on guys.
Rate of change of velocity.
Yes, rate of change of velocity. So you put delta V. Delta V means change. If you divide it by time, you are talking about rate of change of velocity. You understand? Okay, so that is the meaning of it. Okay, so let me check the Zoom window. Okay, so I have a lot of questions, I think. So should we want to write these notes, or you will be giving after discussing? Yeah, I can give you this document, but I don't think this is a good note. But whatever I write will be there, okay, for you. But I don't think this is a good note. You have to use the theory note that your sir gave you, sir or teacher, whoever. So you can use your resource book as a note. So note is, okay, notes are like kind of the things that you need for revision, right? But just try to understand this now, and whenever you want, you can watch the video again, because it will be uploaded to YouTube, right? I don't worry about the number of students. You just come if you can. I will put the recording also. You can just watch the video if you are unable to join. Okay, but I need some people to kind of talk to me during the class. Otherwise, it will be very boring. Okay, so let me explain the acceleration. So acceleration is the rate of change of velocity. So the velocity can be increasing, it can be decreasing, whatever it is, you call it acceleration. As I said, there is deceleration, which is the opposite word for acceleration, but that is not a very physics term. Okay, so that is kind of okay, that is kind of a lay people's term. When acceleration is negative, you call it deceleration. So this is the basic definition for each. Okay, so acceleration has a direction. Okay, if it is increasing in that particular direction, you call it positive. If it is decreasing in that particular direction, you call it negative. Okay, so I will tell you a simple example. So let's throw a ball. Let's release a ball from top of a building, for example. Okay, so it is moving downwards. So you can call it a downwards positive acceleration. Okay, you understand?
Yes, sir.
When it goes like this, upwards, what do you call it?
Upward negative acceleration.
Excellent. So how does it come? Can you prove how it is an upward negative acceleration?
Because it is against the gravitational acceleration.
Because you have to explain acceleration always. Yes. So always the acceleration is in the direction of only force that acts on mg. Its weight, it will be always downwards. Whatever the weight is always pulling it down. Therefore, the acceleration, which is g. When the motion upwards, there will be positive acceleration. When the motion is upwards, it will be a word negative acceleration. Still downward acceleration. Both are correct. Both are correct. But which is more convenient? This one is more convenient, right? Because the motion is upwards. So a person who comes and talks about this acceleration as downwards will be a bit confusing, right? So to be clear, we always choose the easy side. Can you hear me?
Yeah,
Yes,
sir.
Now you can see my screen also, right? Sorry, there is an unstable connection, but it's fine. So I have explained you the basic. Okay. Purpose of this class to CQ points. We are mainly because you know that there is 100% chance for one MCQ to come from this section, right? Sometimes there are two MCQ. One MCQ will definitely be there on linear. So if you can just study of the MCQ questions, score the marks. Okay, so let's start. We're going to have a complete account of linear motion. Here we are just going main concepts. Okay, so explain you the equations that are used in linear motion. Okay, so when we derive those equations, we usually start simple VT graph. So graph make the things easier for us. Okay, use this graph to equations of linear motion. I am drawing of an object which starts at a velocity of u and with the final velocity, the total. Sorry, students. Again, connection. Hello, can you hear me now?
Yeah, sir.
Okay, I'm really sorry. I don't know what's happening with this connection, but I have data, but I don't know. So where did I stop? What was I explaining last? Guys, where did I stop? So I told about proving or deriving the linear motion equations, right?
Yeah, sir.
Yeah, could you hear that? Okay. So this is the graph that we are going to use to derive the equations from. So in this graph describes a motion of an object which started with an initial velocity of u and finished this motion with the velocity v. Okay. The total duration is t. Okay, so now this is a vt graph. So what is given by the gradient of this vt graph? Yes,
Acceleration.
acceleration. What is given by the area under this graph?
Displacement.
That is displacement. So we can derive two equations for acceleration and displacement, isn't it? So acceleration is equal to the rate of change of velocity. So you will put the change of velocity divided by time. Okay. So from this, if I take the time to the other side, it will be at equal to v minus u, isn't it? So finally, you can take v is equal to u plus at. So this is the first equation of your linear motion. Do you understand?
Yeah.
Okay. So the second equation that I'm going to derive is for the displacement. So displacement is equal to the area under the graph, isn't it? So what is this structure?
Trapezium.
Yeah, it's a trapezium. So to find the area of a trapezium, what is the equation that should be applying?
Half into sum of the parallel lines into height.
Yes, sum of the parallel lines into perpendicular height. So this is one parallel line. This is another parallel line. So this will be v plus u. Okay, multiplied by the perpendicular height, which is t. Okay, so people write it like this: v plus u over 2 into t. So this is another equation. Let's call it a second equation. So now there are two more equations to derive. So can you all come up with an idea to derive those equations? Yes? Any ideas? You guys have to do this now. So take your rough sheet. And now can you substitute this for this v? Can you do that? For this b, you have to substitute u plus at. Then let's see what comes. Okay, so I will also don't look at the screen. You have to do your own way and then finally check your answer with my answer. So I'm going to put u plus at instead of v, right? So then I get this. Okay, so now there are two u's. So there will be two u and there is a at. Okay. So, okay, so I will write this in steps. A bit 2ut plus at squared divided by 2. So this 2 is dividing these two, right? These two components. So if I divide them individually, what will I get? These two will cancel each other and there will be a half in front of this component, right? So you get S is equal to ut plus half at square. This is what you get. So this is your third equation of linear motion. There is another equation. What is the equation? You tell me the end product. That is v squared is equal to u squared plus 2as, right? Can you hear me?
Yes, sir.
Yes. So to get this, what should you substitute for what? What is the method in which equation? Just tell me that. What parameter is not there in this equation?
Time.
Time is not there, no? So you have to substitute something for the time somewhere. Where? Here there is t. Here also you can get a t. T is equal to what? Cross multiplication. T comes here, A can come here. So it will be V minus U over A. Right? So I'm going to substitute this for T here. So this is equal to V plus U over 2 multiplied by V minus U over A. So what is V plus U multiplied by V minus U? Huh?
V squared minus u squared.
Yes. It is just a grade 9 method we studied, right? Don't forget those things because they will be helpful. So H2A will come and multiply. So 2AS is equal to V squared minus U squared. So make V squared a subject here. So you get U squared plus 2AS, right? So this is your fourth equation. So there are only 4 equations that you have to study. Using these equations, you can solve all the problems. There will be some fancy equations. Some teachers teach, some teachers don't. But you don't need to know them. For example, the displacement in n second. So those are some fancy things that you might have learned. But those are not standard equations. You can't use them directly. You have to prove and use. But these 4 are the standard equations. You can just use them directly. Okay, you understand?
Yes, sir.
Yes,
Okay,
sir.
good. Yes. So now I will send you this document so you can always have a look at it when you're revising. Now let's do this question. So before that, guys, let me explain the steps of studying physics. Okay. So if you want to become an expert in anything, okay, expert in some field, so they say that you have to undergo a metamorphosis. Okay, you have heard of this word. What is that word? Huh? Have you ever heard of the word metamorphosis? The life cycle of mosquito and all you have studied, right? So it starts with egg. And what does it become? Huh? Larva, right? And then it becomes pupa or something, and then it becomes adult mosquito. Right? Guys, am I right? And it lays eggs again. Right? Huh? So if you want to become an expert, you have to go through a cycle like this. Okay. So now you say you are a dummy. Okay. Then